Welcome back to the Afterword, conversation about the future of words and stories. We are so glad to have Dr. Bill Martin and Dr. Chris Hennon here with us to continue our conversation about weather prediction and the changes over time in meteorology. We hear a lot about weather in the news, yet some people still explain that climate changes are normal. What would you all say about the trends and nuances you are seeing in your work with weather prediction?
So you're interested in weather or climate? Because there's a difference.
Okay, well, why don't you help us understand that?
So weather is short-term changes in atmospheric conditions. And we have a group of models, computer models, that are developed specifically to forecast the weather. And then climate's more of a long-term, I call climate the synthesis of weather. It's like the long-term conditions. Some people think of it as like an average. And when we predict the climate, there's different tools. There's different computer models we use for climate. So there's a difference in what you're talking about. For climate predictions, if we want to talk about climate predictions, we've had some pretty reliable climate models for several decades now that have pretty consistently, forecast that we're going to be experiencing a warming of the climate. It's normal for climate to change. We know that climate's changed in the past, and we've known in the past, before humans have really had a big impact on climate, all those changes have happened through natural processes. But what's different about this particular moment of time that we're in is the climate's changing the fastest we've ever measured it before or ever even simulated it before. And it's quite fascinating that almost all of our climate models are telling us the same thing, and that we're heading into a new era and we're already in that era of a warming climate. So, I would just say that it's climate prediction has been remarkably. I mean, there's differences in the details and the magnitudes and how much and where exactly, but overall, I think we have a pretty high confidence in what we're being told that and how the climate system's changing.
Okay, well, I appreciate the interest and the teasing out, if you will, of those differences. That's fascinating. How about you, Bill?
Yeah, as Chris noted, we're meteorologists and not climate, which are kind of separate fields, although they are related. I'm not an expert in climatology. My understanding is there's been about a 2 degree or more Fahrenheit increase in temperatures over the last 100 years, which is about 0.2 degrees Fahrenheit per decade, which if that trend continues another 10 years, that's, 10 years from now, it's going to be on average 0.2 degrees warmer. And would you notice that difference? I don't know. Of course, it could be more than that. Again, that's predicting the future is complicated. In terms of weather, 0.2 degrees every 10 years is not something we take into account in our forecast models for weather. It does impact weather forecasting maybe a little bit because it changes the kind of weather you get, perhaps. Do you get more tornadoes, more hurricanes, more droughts? I don't know if you get more of those. Maybe you do. One thing people tell me they have noticed who've lived here a long time is that we get less snow than we used to. I think that's perfectly reasonable. That's something you might have noticed if you were alive here 50 years ago, that you had, every year you get a foot of snow. And this year, we've gotten 6 inches so far this year, so that's a start. So we get less snow now than we used to. So that is a difference. So, okay. But it's not, what weather forecasting per se, though, it's not directly related to what's going on with the climate. And we usually don't worry about it. So,
okay. That really, again, that helps clarify things a little bit. Now, we just got a very new Washington Post report, the data from the NOAA organization, NASA, and Berkeley Earth, that this past decade was the warmest on record. And so what are some of the ways the average person can help prepare for aspects of changing weather, Bill? What do you think?
Changing weather is still going to be weather. I mean, if you get more hurricanes, but you still need to prepare for hurricanes. You get more tornadoes. I don't know that you'll get more tornadoes or not, but if you do, you still need to be prepared for tornadoes. You still need to prepare for droughts and floods. the kinds of things you need to be able to deal with. You're going to get those things. You've always gotten those things. You're always going to get them. If you get more of them, you get more of them, but you need to be prepared for that sort of thing. I would say, if you're in agriculture, maybe you can think about what kinds of different crops you might be able to grow if things warm up another degree in the next 20 years or something. But I would say, as I point out, climate change is a slow process. And you have time to make those decisions. It's not like suddenly next year you're going to have a completely different climate. It is a very slow process. Even if it's speeding up, it's still going to be relatively slow compared with a lot of other things. So I think the good news is that you have time to make these decisions. You'll get, and the other point I had was that, weather is something you need to be prepared for anyway. So there you are.
Okay. Good point. What do you think, Chris?
Yeah, I agree completely with what Bill's saying. Climate's something that changes, even though it's changing rapidly. When I say rapidly, I don't mean it's changing every week. It's something that changes over decades or even centuries. So there's really not much like somebody living in, Little Rock, Arkansas would really need to do to prepare for changes in climate. Kind of an analogy I might offer is like with hurricanes. If you live on the beach in Florida, and somebody makes a prediction, we make seasonal predictions of hurricanes. Like, how many hurricanes are we going to get? How many of those are going to be strong, or how many of those are going to hit land? You hear that prediction in April. So what are you going to do about it if you live at the beach? Well, nothing really. I mean, every year you're going to take preparations. You're going to maybe have a hurricane preparation kit. But there's really no special actions you're going to take, because you won't know if the hurricane is going to affect you personally until maybe 3 to 5 days away. And that's when you really start taking action. And that falls in the regime of weather, right? That's weather forecasting. Okay. That's not really a climate forecast issue.
Okay, excellent.
What does it take to be a weather forecaster? How has this role and the preparation for this role changed over time?
Well, to be a quote unquote meteorologist, I mean, there's a lot of people out there now on the internet that claim to be meteorologists, and they do their own forecasts, which I'm sure Bill can comment is not ideal. But to be considered a meteorologist, typically you need a meteorology degree. And to get that degree, you need to take a certain number of courses that are specified by Bill's employer, as well as the American Meteorological Society, which is our professional society. And you get your degree and you're a meteorologist. But if you want to be a forecaster, you can be a forecaster, but it takes time to get the experience. It's not just a matter of looking at computer models and saying, here's what's going to happen. You need to develop an intuition about forecasting. You need to gain some experience. You need to just live through several different types of events, and you start getting kind of an inner guidance about some of these things. And, the really good forecasters are the forecasters that know, what to focus on, what not to focus on, what's the important considerations. And that's really how you become a good forecaster. But just to be a forecaster, you just need an education, and you can be a weather forecaster.
Okay. What would you say, Bill?
Yeah, I agree with all that wholeheartedly. I like to think that meteorology is an application of math and science. You need to sort of like those areas. Math is important, even though our forecasters are not using math every day. In fact, they're not directly doing calculations. They're looking at model output. They may be thinking about the physics of it, but they're not doing the math. Yet math, I think, is important, not just to understand how they work, but just to have a sort of logical and reasonable way of looking at things. Mathematics is really applying logic to make deductions. If you're good at math, you'll probably be good at weather forecasting as well. I mean, that said, a lot of our forecasters would say they didn't like math as was one of their least favorite subjects, and they're really good forecasters. But I think they would be good mathematicians if they wanted to, because they're very smart and logical people. The other thing we look for nowadays is the ability to communicate the forecast, especially in the weather service, where we make a forecast, and if we need just having a forecast isn't doing any good if no one understands it or sees it. And half of our job nowadays is getting that word to the public in some sort of easy to digest manner. We have training on how to use social media, for example, how to do briefings, how to write. All those things are important. So let's say, it's be good at everything is glib, but the better you are at everything, the better you will be in meteorology. So,
okay. Well, and I do appreciate the multifaceted approach to it and how it does take, as you were said earlier on our other episode, people and computers, but then it's also part of the communication. And it's interesting, Chris, you're talking about, people on the internet can say that they've got that background, and that can
that's the thing. If you could make a perfect forecast, but if you can't communicate that to people in the proper manner, in an efficient manner, an effective way, then it's worthless. And it seems that there's a lot of people out there who are very efficient at social media, who may have a Facebook page with lots and lots of followers, and they issue their expert weather forecasts, and they reach thousands of people, and some of them may not be meteorologists. And so it can be dicey if you have large swaths of the population listening to people making forecasts like that. And what motivates those types of forecasters? It's having people come to their websites or their blogs, and the more people that come, the more popular you are, the more advertising you can get. So what are your forecasts going to be? They're going to be for maybe worst case scenario, right? And then maybe you're responsible. So it can get real dicey in the internet streets with weather forecasting.
I would imagine. So it's interesting that the negative forecast is what populates more interest.
Just like with anything, what gets the eyeballs? It's conflict. It's raising the fear levels, right? And how do you do that? You just, a cold front's coming through. We might get an inch of snow. Well, that's a normal thing. That's not anything to get all worked up about. But the internet forecaster is going to make, it's possible we'll get 5 inches. Possible, but that's what's possible. I'm going to walk outside my door and get hit by a bus, but it's not likely going to happen. So that's the type of language you're dealing with. Yeah.
Okay. That makes perfect sense. So let's look into the future a bit, because as you all have shared, the field of meteorology and this study has really taken off since, prior to World War I. It's changed over time. What do you think will be some of the most significant developments or inventions that will take us to the next century with weather prediction? What do you think, Bill?
Well, one thing you learn as a meteorologist is that forecasts for the future are fraught with danger. There's so many, you never know. That said, meteorology has always benefited enormously from developments in computer science. And I think computers have some ways to go yet in their development, and this is going to benefit meteorology as computers get more powerful. Currently, our highest resolution operational forecast models can resolve individual thunderstorms, but they can barely resolve them. And getting better resolution of things like that, of individual storms, I think will benefit our forecast significantly. This will not be a huge advance. It won't be as big an advance as the invention of computers by itself. I don't think anything's ever going to match that. As I mentioned, there's a limit to how far into the future you can forecast, no matter what. No matter how good your models get, no matter how good your observations, there's a limit. And the limit is around 2 weeks. And we're, so eventually maybe you'll get a forecast that's reasonably good 2 weeks in the future. And right now we've got maybe 7 days. So we've got a good chunk of what's possible already done. And so while it may be possible to do more, I just think there are limits there. But I think the development of the computers is one that will surely happen. There are other things that could occur, like weather control is theoretically possible, but it's just not practical. I don't think that's ever going to happen. It's way too expensive. Doesn't happen, but it's possible. Prove me wrong. So.
Give an example of what you mean by weather control, because in my mind, I'm thinking, an airplane is dragging clouds everywhere. But
early attempts at weather control was things like cloud seeding, which are marginally successful. And some people still do it, but it's not done on a large scale. In terms of weather control, I'm thinking more controlling entire weather patterns by having global arrays of things that perturb the atmosphere in just the right way to get the right effect. It's, again, a very complicated, difficult problem that the people who invented numerical weather prediction wanted to do that. and they couldn't. They were way away from being able to do that. We still are nowhere near being able to do something like that. It's just too difficult and too expensive. So.
Okay. All right. Well, thanks for clarifying that. Chris, what do you think?
I've been doing some work on artificial intelligence and machine learning. And basically what we're doing is we're taking the computer forecasts that Bill and his forecasters look at, and we're seeing how well those forecasts have done over the last couple of years. And we feed that information into what's called a neural network, which is basically computer code that tries to simulate how the human brain works. And the power in that is you can find patterns in the data that would not be immediately obvious to like standard statistical techniques. And we've actually shown you can improve weather forecasts 20, 30, 40% just at one day in the future, by applying this artificial intelligence. And there is movement already happening, I think, at the federal level towards using these tools in weather forecasting. And I really think that's something that's going to become more and more endemic in weather forecasting. And Bill might disagree with this part of my prognostication, but in my view, I think eventually, and I don't think it's that far in the future, maybe 20, 30 years, I don't think there's going to be really a need for humans much. There still might be some need for human forecasters in very high impact events, issuing warnings and the such, but I have this feeling that, a couple decades down the road, I think weather forecasts are going to get so good that I don't think for routine forecasts, I don't think we're going to need to have weather forecasters sitting in front of a computer all day. Bill, what do you think about that?
Well, yeah, maybe 20 years it's possible, but I guess people have been saying that for some time. I entered the Weather Service in 2007, and that was a topic of conversation then. That was, how many years ago was that? 15 years ago. It's possible, but I think experience still counts for a fair amount. And of course, the need to communicate the forecast is still going to be there. And the other thing that we do that I don't think you can simulate is the decision to do something like a tornado warning would be extremely difficult for an expert system or an AI system to do. I think the fact that we do warnings, we do watches, we do a blizzard warning, whatever, we do these headlines we put out. And the decision to put out or not is difficult and subtle and depends on a lot of factors. And I think that gives us a certain amount of job security as operational forecasters. We'll see.
Okay. Well, this is absolutely fascinating. And, we've done several episodes on artificial intelligence and, that fear of the possibility of being replaced by the robots. And so it sounds like it could be a both and. Maybe that AI meteorologist is sitting there in front of the computer, but it's the person who finally pulls the trigger and says, okay, we've got to actually do the warning. So someone's going to have to manage that AI, I guess, a little bit.
Maybe.
Okay. All right. I love it.
What's a metaphor to help us understand weather prediction?
Well, I can give you a metaphor I've seen recently on social media of cookies. In the Weather Service, we have watches in the morning, where a watch is issued if severe conditions are expected to develop, and a warning is issued if those conditions are actually present. And this picture I see on social media is a picture of a cookie. That's a cookie warning. And it's a picture of flour and sugar and chocolate chips, the ingredients of a cookie. That's a cookie watch. And that is true because, in meteorology, we think of the ingredients that make certain kinds of weather. Like a tornado, there are ingredients in the weather that make tornadoes. You have a certain kinds of instability, a certain kind of wind shear, a certain kinds of synoptic patterns and moisture and different things. Those are the ingredients that make a tornado. It's a little more complicated to make a cookie, but I think that's a really good analogy.
All right. So the watch is the ingredient sitting on the counter.
The ingredients are there.
The warning is actual the cookie. Is the chocolate chip cookie there?
That's the warning. Cookie warning.
Oh my goodness. I love this. This is great. All right. Thank you. Chris, what do you think?
Well, this could be a stretch, but I like to play poker.
Okay.
So I'll use poker. So in poker, you're sitting down at a table with 8 other people and you're dealt cards, right? And there's information you know what your cards are. So you can make a prediction about who's going to win the hand, but it's just based on what you know. So if you have a really good hand, you're likely to win the hand in the end. But there's unknowns, right? There's other people's cards and somebody else might have a better hand than you, or everybody else might not have anything. And in the weather, there's lots of unknowns. There's lots of, you don't measure everything directly over the oceans. You don't measure the conditions there. So there's lots of unknowns that could affect the outcome of weather prediction. And even if let's say you knew everybody's cards and you knew exactly where you stand at that moment in time, you still may not get the prediction right because there's some random things that could happen that would alter that outcome. So I guess that's a metaphor for prediction I would offer.
I love that. Yeah. And I guess at some point you just have to know when to fold them and just say, I'm done,
Yes, absolutely. And I need to do that more.
There you go. Well, thank you. These have been great metaphors.
Thank you so much. Chris, where can folks learn more about your work or connect with you?
You could just search for me at UNC Asheville. There's a website. It's weather.unca.edu. That's kind of our department website. Okay. And then I have a personal website as well with some more information about the work I do and some of my interests and stuff. And that is cyclone.wp.unca.edu. Okay. So those would be 2 places where you can find out more about some of the things I do.
Wonderful. Well, we'll make sure we link that to our show notes for sure.
Bill, how can listeners connect with you and learn more about what you're doing?
Yeah, I can be found in a couple ways. There is something called a NOAA locator, where NOAA is NOAA. NOAA locator is basically a phone book of everybody who works for the National Oceanic and Atmospheric Administration. If you go to the NOAA locator, type in my name, Bill Martin, you'll get my email address and feel free to contact me. The other way is to call our office. If you go to weather.gov, the GSP office for Greenville, Spartanburg, and there's a phone number there for our office. And you could, there's also an email for our office that's checked once a week. So I would eventually get a message if you send it to our office email, or you can leave a message by calling the number there. So
Perfect. Well, Bill and Chris, this has been an amazing conversation. Thank you so much for your time, as we've just learned a lot about weather prediction and how meteorology has changed over time. So thank you so much. Appreciate y'all being here.
Thank you. It was great talking to both of you.
Yeah, it's fun.
Join us next week for a conversation about how history has been affected by natural weather occurrences in the world.
That's going to be exciting as we continue our theme about weather. And we want to ask you to please leave us a review, rate us on Apple Podcasts, become a subscriber to theafterwordpodcast.com. It does help keep the conversations going. And as always, you are welcome at our table.